Hi everyone, this is Venkat and welcome to my channel. Today I'm going to start my first Zero to Hero series of Unix and Linux fundamental, and I'm really excited to share my knowledge with all my subscribers and who are yet to watch or who are yet to subscribe to my channel. So they will definitely get good information in this particular series. So without wasting of our time, let's get started. So today is the day one of Unix Linux fundamental of 02 Hero series. So before I deep dive into all the topics, then I wanted to talk uh, about the content. What do you expect from the day one, right? So in the day one, I'm going to talk about OS and history. Yes, as a member or as a IT employee, you need to know what is OS and evaluation of OS, right? So that is important. But when you go into real time, the evaluation is not required, but you need at least some fundamental knowledge on the OS. What is OS? How do we use that? What kind of OS we have in the market? Like that, I'm going to explain in details. Then I'm going to talk about the open source module. It's nothing but how the operating systems can be divided into a commercial or freeware, like that. So I will deep dive into those categories as well. And next, I'm going to talk about the distribution. Distribution, like in the market, there are different vendors out there. They will provide operating system with the and by charging some amount of money. So I will talk to that and why they are charging and what is the benefit of that and all into the distribution topic. And then I will talk about the Linux operating system. That's something important to understand. As a team, you need to know like why that is operating system being used and how the internal architecture is designed. Those kind of things I'm going to talk about in this. And finally, I'm going to talk on the workstation, client, and server module. Like this term, like when you going to be any interview or any um, already you're working in your some X company, or there you might hear this term called client and server very regularly. So I'm going to talk about uh, the differences, and I will show you the differences of workstation, where to use the workstation, where to use the client, and where to use the server and all, right? So that's it about this day one session. And mm, most of the information today are something like basics or fundamentals. So today I'm not going to execute any commands on the screen or on the putty session, whatever. So or rather I will explain theoretically on these all topics that I mentioned in the day one. Okay, so now let's talk about operating system, right? So before we go into that, right, so many of you people already aware of operating system. Means what is operating system, uh, where do we use and how to use in real world cases and all. So before I deep dive into that, I want to take one example in our real use case. Let's say example, um, you have a mobile, right? Some XYZ mobile. I mean the hardware model, like maybe a Samsung, Apple, or any other brand phones. So in the phone we have some operating system, right? I mean some OS is installed. Like you might hear that your software is getting updates. You need to update, or else you will be having some kind of security breach or like that. So that operating system is something provided by the company. When I say company here, let's say if it is Samsung, they have their own Android OS version and they develop it, and they will give it. If it is a Mac system or Mac phone, they will have their own uh, Mac operating system versions and all. So they will provide some OS. So on top of that, as a end user, like as your end user means as you or me who are using that particular device, we are installing our own apps. Let's say you are um, dealing with your Zomato or dealing with some Facebook or dealing with your any application that you want, you can install simply, right? So like that, in order to deal with something um, on the system, then you require one operating system. So when I compare with this mobile thing and all, right, so hardware it's a mobile, and on top of operating system it's your OS, like maybe Android OS or iOS. On top of that application is nothing but your maybe a Facebook app or WhatsApp app. On top of that we have a user. So user means nothing that you as a user and you want to interact with your hardware. So operating system, it's a behind the scene, it is having a lot of what do you call, some programs or applications that will give you a good interface between the user and your hardware. So let's say you are trying to store some data, or you're you have a video and you want to store somewhere in your system, you must need a one platform that is called OS, right? So when I talk about OS definition, so OS is nothing but operating system, system software that manages computer hardware and software resources and provide a common services for computer programs. Means, as I said before, as a user, if you want to deal with your hardware, then you must need some operating system. So that operating system is having a software resources and common services or common applications that will give a interface. So when you talk about actual meaning of Wikipedia or whatever. So an operating system is a system software that acts as an intermediary between computer hardware and users. So it provides a set of essential services and functions that allow user and application program to interact with the computer hardware. Means you cannot directly interact with your hardware. You must need some software program that is called operating system, right? So the primary objective of an operating systems are manage the resources, provide user interface, and facilitate the communication between hardware and software components. So when I say manage the resource means it can be our CPU or memory. Let's say you have a PC and you're using that PC for gaming use case. So when you open your gaming application, that application requires some amount of memory and CPU as well. That kind of something resources are managed by the OS. And interface, when I say interface, the way you accessing your PC, uh, and how what you are getting in the PC screen, that's called interface. Means you will get a GUI mode or you will get a CLI mode. I mean, no worries, you don't need to confuse about what is GUI and CLI. I'll talk more, but that's called user interface. Okay. And facilitates the communication between the hardware and software. Means, as I said, you as an user, you cannot directly interact with your hardware. You must need some application or the utilities to interact with your hardware. As I said before, let's say one more, I'm giving one more example, that let's say you have a open office software, sorry, Microsoft MS Office. So if you want to store, if you want to create Excel file or CSV file or just Word document, you need that Microsoft Office software, right? So that software you install, and as an user you open that Microsoft MS Office software, and then you create your document and you are storing. So when you save that file, that will automatically stored in your PC. So here in the PC means like hardware, right? So when you talk about the operating system common features, right? So most likely it will handle the process management and memory management, and file system management and device driver management, network management, and security management. So when you talk about process management, it's creating, scheduling, and terminating the process. So what do you mean by this? Means, let's say in your Windows machine you just opened one file or maybe one program, that is called creating. And scheduling means there are some batch operations programs are there. So when you open that process, it will automatically scheduling like when to run, how to run, like that. And terminating means when the program need to be terminated, or when you are going to terminate. Let's say the process you are not anymore going to be using, then you can terminate, right? So this kind of this kind of process management or something handled by the operating system. And also allocating resources to the process, this is key functionality of the OS. Means, as I said, when you open a program or a file or something that requires some amount of resources, right? So that resource something allocation done by the operating system. And next one is something like memory management. This is very important. You cannot run let's say your machine is having a 16 GB of memory, and if you try to run application which require more than 16 GB of memory, then your system is going to be a hung or might not be um, respond to your program query or whatever, right? So the memory allocation also is something it is handled or controlled by the OS. And next one is, as I mentioned, file system management. So file system management is nothing but organizing and managing files and storages, right? When I say storage here, your hard disk. So in general, end of the day, whatever files you are storing, it can be a file, or it can be a video, or it can be CSV file. Everything you need to store somewhere in your system. So that's where the file system management will comes under, and that is something organized or managed by the OS. The next one is very important, that is the device management. So what do you mean by this device management? Let's say your PC is having a different input and output devices such as printers, keyboards, and disks. So when I say disk, maybe your machine might having internal disk or maybe external disk. So when I say external disk, maybe your external hard disk, right? The way you connect to your USB and you will work with that hard disk and you will unplug it, right? So like this, the device management also is something controlled by the operating system. And some, as I said, some security also, like what kind of um, what do you say, authentication or other issues need to be done on the system side. Let's say in general you can access your system because you are the owner, right? The way that controls the giving granting the permissions to the user, that is also something handled by the your operating system. And also there are some user interface, as I said, you will have a very graphical user interface or CLI interface, and it's all depends on the OS to OS. So you will have a, if you take some older missions, you will get only CLI, like 80s, 70s, 80s um, generation of operating system. But nowadays most of the operating system supports both. Okay, but it's all based on the use case. But generally when you are working on real time, you will not get any GUI mode. GUI is nothing but graphical user interface. Most likely you will deal with the CLI. So I'm going to explain what is this CLI and GUI and where to use whenever it's needed in upcoming session. So this is all about the operating system. So in a short, it's a set of programs that act as a link between a computer and user. So user need to write something, then there is some link. The link is nothing but here OS, like it's a bridge. Just example, think about it is uh, it's a bridge, right? So there are some couple of popular operating systems we have in the market, like Microsoft Windows, Mac OS for Apple machines, Linux based systems like Ubuntu. We have a Fedora, and Unix Android based, which is for mobile devices. Like that, we have a different categories we have, right? So yeah, so as I said before, right? So this application, right? So this application will interact with your memory and CPU and devices. So how it is done behind the scene, in between there is a concept called kernel. So kernel is the heart of the operating system, so that will contain everything to run your application smoothly. Okay, so I'm going to talk about kernel, what is this kernel, and how it is interacting with your user and your hardware, behind the scenes. So I have one more slide where I can talk in detail about the kernel. Okay. Yep. Now coming to the operating system. So when I say operating system, right, in market we have a number of operating system, but before that, how the operating systems are categorized into different types based on their features and design or intent for use, right? So there are some common types of operating system we have. So the first one is something like single user and single tasking. So what do you mean by this single user and single tasking? So generally it is designed to support one user and execute one task at a time. So name itself, it is saying that single user and single tasking means you cannot run multiple programs at the same time, and only one user programs runs at the same time. Means the single user can access and single user can run a single process at one time. You cannot run more than one. So the best example is for, let's say, in the earlier like MS-DOS, right? So the personal computer, it's known as for personal computers like MS-DOS. MS-DOS is one of the example for single user and single tasking. So do you believe this single user and single tasking machine is useful in this generation for use case? No, because if it is a single user with a single tasking, no, we cannot use that kind of operating system anymore. That's the reason, I mean, how the evaluation is done is then they introduce like single user with a multitasking. It is slightly differences that allow one user to run multiple applications simultaneously. That's the one of the added advantage of the multitasking. Means one user can run multiple applications simultaneously. So for example, modern desktop operating systems like Microsoft Windows, Mac OS, Linux, all all these systems are fall into this category, right? So multi-user, right? Sorry, multitasking. Multitasking means, let's say this, now I opened one program. I mean, the program called like PPT. So this PPT is simultaneously running. At the same time, I am also running another process called recording. I am also doing my recording, right? So these two processes are something I connected as a single user. Nobody is right now connected to my PC or my laptop. I am the one who connected, and I am running a multiple tasks simultaneously. That is called a single user and multitasking. Yes, this is useful when you work for as a single user like me. Like you are the owner and you want to do everything on the machine or on the system. Yes, you can go with this kind of operating system or this kind of operating system type. The next one is multi-user. So this is the one we are using right now, multi-user with a multitasking. So as I said, it supports multiple users. Users can connect simultaneously, and users can have a run multiple tasks independently. When I say independently means, let's say this is my just example. This is my server. Let's make my PC. Just assume that my PC is my server. So any number of users can connect to my server, and they can run their own process or they can run their own programs. How this is managing, like user one is connected, user two is connected. So these two users can run their uh, their programs independently. I mean there is no clash in between them. So how it is something handled behind the scene, the operating system will take care of about that process allocation and process termination or resource allocations. Everything that is something handled. So multi-user is the very popular OS right now we are using in the market. Okay, so whatever nowadays we have a server editions like Windows 2012 uh, um, and and Linux. In the Linux, we have a different editions like Red Hat. Not only Red Hat, CentOS, whatever. All this comes under the multi-user and multitasking facility. And apart from that, we have a few more operating system models like distributed operating system. Means we are sharing our uh, extend capability of a single machine by linking multiple computers in a network. Means let's say you can club all four or five machines with some uh, some network topology, and then you can distribute your operating system. Example, we have a DFS. DFS is nothing but Windows distributed file system, right? So that is one kind of example for the distributed operating system. The next one, we have a network operating systems and a mobile operating system or embedded operating system and batch processing operating system and multi-processor operating system. So all these categories something we as a user we are using based on the requirement. So when I say based on the requirement, most of the time we use the multi-user and multitasking. So because those are really uh, designed for the server edition. Okay, it's not for the normal use case. Okay, now let's
Yeah.
talk about the history of operating system. Right, this is in general, this is not required for your interview, or maybe you are attending any interview, or it's just for your shake of knowledge. So you don't need to worry. You don't need to worry about who introduced it and on which year this is introduced and all. So all you need to know is only how the operating system evaluation is done, especially the Linux. I'm talking about Unix and Linux, not the Windows or any other operating system. Especially this is for Unix evaluation, right? So what happened in 1960, right? There are different people. They try to create a they try to create a multitask. Their aim is to create a uh, multitasking, multi-user operating system. So the way it's evaluated is initially they created one operating system that's called Multis. That's a project. So Multisk is nothing but multiplex information and computing system. So that is the first project where the aim is to have anybody can connect to the machine. They can run their independent jobs and all. Then what happened? Some X region, some X factors, what they have done, they done couple of changes to that particular project, and they introduced another project called Unis. So Unis means Uniflex Information and Computing Systems. That's the first project which is launched in 1969. So that is the another. The first project where your uh, multi-user multitasking slowly is evolving. Okay, then eventually what happened, they rebranded or they changed the name into the Unix. Okay, before that it is a Uniflex Information and Computing. Then they started that name into the Unix. So what happened in between? There are a couple of people who think about, okay, we need to rewrite the Unix kernel, and that can be having for portability use case. So they tried rewriting the Unix kernel in C, with the C language, with some of the modification on the existing kernel like in the Unix. And the goal is to have a portability OS. So what do you mean by portability? Portability is nothing but that can support any hardware or any platform. Means this example, you create a program with A that should support on all the hardware platform or any other operating system models. That's the called portability. So portability, the main aim of this is to, I mean, the rewriting design is that to have a portability operating system, right? Then what happened in 1991? Then Linus Torvalds is introduced the free Linux open source, which can use for different PC or different hardware. That is the first uh, free open source OS launched in 1991. Okay, so in between what happened, like you might be I just explained, like in 1960 started, and the first multitasking or multi-process operating system started from 1969. So what happened in between actually? So in between there are different editions are released. As I said before, they evaluated, they rewritten or they modified the operating system utilities or applications, the interface, whatever. In between they modified, like they have a modified in the 7th edition, 5th edition, like that. Then finally in 1983 and between 19 in the 1973, there are two kind of models are available for end users to use that operating system. So there are two models, as I said. One is BSD. BSD is nothing but Berkeley software distribution. That is one way of a distribution model, and another one is something System V, right? So System V is something introduced in 1983. The goal is to have a commercial versions like HP Unix, IBM, IBM AX. All these are something fall under the uh, System V model. So you might be confusing what is the System V and BSD. So I'm going to talk about in the next slide what are the key differences in between them, like System V and BSD. So today whatever we are using, like Linux, it's not purely on a System V or BSD. Is rather it's a combination of both the features. So I'm going to talk about in detail differences between System V and BSD model. Okay, so after that what happened? As I said, in the System V there are OSs, like said before, HP Unix, AX, Solaris, Sun OS, Sun Microsystem OS. Now it's acquired by the Oracle basically. So all these are falls under the System V category, and BSD model, like Berkeley software distribution model, right? So those are something like very open source based operating system. Okay, then in 1991, as I said before, Linus Torvald is the person who introduced this Linux operating system for for the end user use case. So the project is, as I said, it started in 1973, 1960, then 1969, then 1978. Like that, the evaluation is done from top to bottom, and every releases they try to modify the operating systems core functionality or utilities. So this is what the brief information how the Unix or the Linux evaluated from 1960 to 1991. So after 1991, yes, there are other flavors of Unix are introduced. We have a different flavors out there, like Fedora, CentOS, or all these are started from the base of uh, Linux, right? So which is open source. Okay. So next, we're going to talk about, as I said, what is the difference between System V and BSD models. So as I said, System V is one of the module um, where this is something developed by the AT&T its team. They are the one who introduced this System V model, right? So in late 1970. But BSD is a Berkeley software distribution developed at the University of California, Berkeley, and was something open development model. Open development model means everybody can download and they can use freely. You don't need to have any licensing and all. But whereas in System V, you must need to purchase the license to use the particular software. As I said, HP Unix, IBM AX is something like not a free OS. You need to purchase the license. I mean OS. You, you need to have that license installed, and then you need to use it. So what is the key differences? As I said, I mean you don't need to have uh, information or experience on the system view, because nobody using right now are the system view models. I mean to say, yes, there are few customer out there, they're still using the system view based operating systems, like I mentioned, IBM AX and HP Unix. But most of the time, as I can see, 90% customers or workloads running on the BSD models based operating systems only, like Linux or Red Hat Linux, or any commercial versions like that. Okay, so what is the differences in between, right? So let's say if you think about the internal architecture of system V and BSD model, right? So kernel something that resides on the under the slash Unix, that is one kind of folder. Folder is nothing but a directory when it comes to the Unix terminology. So I will talk about what is this folder and what is this directory and all in the day two of the series. Okay, so kernel something that's stored on the slash Unix on the system we based system, but whereas in BSD models that's something available in under the slash VM Unix. And shell is something in system we have a sh shell, con shell, she for the BSD model we have she shell and t shells, right? And the boot I mean the way it is booting, the way system need to be boot, or how the programs need to be started or stopped, these are all something called a run controller scripts. So those are something maintained by /etc rc.d on the system v model, and on the BSD it's something like rc dot star, like maybe rc dot 1 2 3 like that you will be getting. And fs block is nothing but that's a file system block, where you will have the every file system will have some default mm, size of it, one chunk, something like that. So I'm going to talk in detail what is this fs block file system while we are talking about the file system management, right? So in BSD it is something one block equal to something 4 KB, and max is something like 8 KB. So this is something high level differences between system V and BSD, and you don't need to um, worry about this in detail information on this. So what do you need to take away from this particular slide? So only you need to understand that system V is not something a freeware, right? This is something they use for, I mean they have their own licensing terms and conditions, and that's something provided by the AT&T, and you need to go pay with that particular licensing. Whereas in BSD it's a free, you can use it as long as you want. Okay, you don't need to um, worry about your copyrights issue, whatever, since it is most likely on the free based architecture. Okay, so now let's understand. So what is Linux? Does it fall under a system V or BSD model? So when I say Linux, Linux is not something uh, either a system V model based or a BSD model. It's rather it's combination of both. Means it will take some features from system V and take some features from BSD. Together, it's a popular OS. So Linux is a popular open source Unix like operating system kernel. So it has a different distributions and all. So I'm going to talk that as well in upcoming slide, right? So yeah, this is all about the um, differences about your SysV and BSD models. That's it for now, right? So you can follow me on the Facebook, or you can follow me on uh, my Instagram channel, or you can follow me on Telegram. So where you will get any PPT or any content that I'm going to create, I will share on that my Telegram channel. So I hope you like this video. So kindly like, share, comment, and subscribe to my channel.